Hello, good morning, good afternoon, or good evening, wherever you are on the planet. Welcome to Earth911's Sustainability in Your Ear. This is the podcast conversation about accelerating the transition to a sustainable, carbon neutral society. And I'm your host, Mitch Ratcliffe. Thank you very much for joining the conversation today. Concrete, as we've discussed several times on the show, is one of the biggest sources of CO2 emissions in the world, accounting for between 6 and 8% of annual carbon emissions. In the United States, we use 415 million cubic yards of concrete each year. That translates into about as much concrete as is in Hoover Dam being poured every 3 3/4 days. And that's just in the United States. Our guest today is Alex Hall, CEO of Concrete.ai, which uses an artificial intelligence-based mixing platform to create affordable, low-carbon concrete for any job based on the application and the available materials. Concrete.ai claims its mixing solution reduces carbon emissions by an average of 30% compared to traditional concrete, and its goal is to eliminate 500 million tons of concrete-related emissions annually. The built environment is going to evolve constantly, and nextcity.org reports that 75% of the infrastructure that will be in use by 2050 has not yet been built. In other words, we have to pour 3 times as much concrete as exists today. And that calls for an immense amount of concrete. Of course, we need to avoid the emissions associated with that growth. And if we are to provide housing, workplaces, and everything that connects humanity on an equitable basis in a decarbonized world, we have to find a way to lower the carbon footprint of concrete. Concrete.ai's technology, which is called Concrete Copilot, is an interesting solution because it can be applied to many different combinations of materials. That's especially useful in locations and particularly lower income countries where materials are in short supply and therefore expensive. You can learn more about Concrete.ai at Concrete.ai, and we'll get to the conversation right after this commercial break. Welcome to the show, Alex. How are you doing today?
I'm doing fantastic. Thank you, Mitch. How about you?
It's early in the day, but it's always a good start to have a conversation like this. And I wanted, the idea of combining concrete and AI, one of the oldest things that we've made as a species and one of the newest things, is really interesting to me. What was the inspiration to do this?
Well, myself, look, I've been in the concrete industry the better part of 25 years, and I think there's always been an ambition to better understand how we can design concrete. But the reality is that we've really never had access to the high-level computation ability that artificial intelligence and specifically the models that we've developed provide. I mean, in the simplest form, I think the way to think about this is artificial intelligence provides us the ability to model in effectively an infinite number of dimensions with all different elements within that. So you're not kind of stuck to traditional maybe 3, 4, 5 dimensions that you're modeling to, which most folks can do pretty well in an Excel spreadsheet with a couple of macros.
Right.
The complexity of the actual product is such that you do need to have multiple dimensions within to model, and ultimately I think that's what this marriage of concrete design and artificial intelligence in that sense really has opened a new portal and given us a whole lot of different insights.
It's really interesting to me, the idea that you could get carbon efficiency out of the same materials that we were using before, but simply by mixing them differently. How many more materials could somebody consider for use in a load of concrete than before? I mean, as you said, it was 4 or 5 dimensions previously. Let's say I'm in Saudi Arabia or Ethiopia and I need to use local materials. Is it literally the case that now we can expand the content of concrete in order to lower its footprint?
At the end of the day, AI is just data, right? I mean, that's the fundamental premise that determines how you're going to apply artificial intelligence. You have to have access to some kind of data, and you have to manipulate the data in a certain way to give you a certain benefit. So the answer to that is it's possible, provided you have enough data regarding the input materials. With concrete, the challenge is it's super complex because, and industry hates me saying this, but the reality is almost every single ingredient that goes into concrete is a commodity.
Yep.
So, ultimately it's the cost of distribution that really differentiates a lot of things. Of course, there's performance elements, and of course, there are things like embodied carbon that make a difference in terms of trying to optimize a product. But ultimately, if it doesn't make sense economically, it's very difficult to substitute a material. So that is really one of the fundamental challenges and one of the unique opportunities that AI does bring us, but with the caveat that you really need to have data. And so to the example you were bringing up, if you're thinking of, a relatively remote place, be it anywhere in the world, you would still need the underlying data as it relates to those different ingredients. So probably one of the most important things you'd need, for example, would be understanding water absorption and fineness modulus and the gradation of the various aggregates that need to go into that. And if you had enough data, you could definitely start moving in a direction to start having some significant savings, even without introducing new materials.
So where did you get the data to train the AI and test the system's ability to assess the mix and predict its functional performance, as well as shorten the time it takes to mix the concrete? Is another element I understand that is critical to the lower embodied carbon.
Yeah, so this is actually a project that's been going on for the better part of a decade. So the work was originally started by Professor Gaurav Sant at UCLA. Gaurav now heads up the Institute for Carbon Management at the Somili School of Engineering and Applied Sciences, as well as a gentleman called Matthew Baushi. Matthew is a professor at UCLA. I actually came across Gaurav in 2016, so I can talk to my initial introduction with the first set of data that came in. And at the time, I was working for a cement manufacturer called Holcim. They're the largest manufacturer of cement on the planet, but I was looking after their ready-mix performance group at that point. I'd seen a Ray Kurzweil article about the future of concrete, and it was a photo of Gaurav holding up it looked like a 3D printed concrete filter, which ended up being a product that had been developed that absorbs CO2 in the mineralization process. So I read this article and I thought, I've got to meet these guys. And what they're doing is like next level, and this has got to have some positive benefit from a from a deployment aspect within the concrete industry, but potentially it's a huge risk to the cement industry as well. I mean, this is a substitute product, and if you could make it at scale and make it cheap, this is the problem. Cement's super capital intensive. Probably going to cost over $1 billion and 10 to 12 years worth of permitting. So that, let's figure out what's going on. And I was on a plane within 2 days. That technology became a separate business called Carbon Built. Carbon Built actually won the X Prize for Carbon in 21. But the discussions on concrete specifically and AI applications really happened then. And I got permission to share some data with the guys from UCLA from Holcim. And they started working on the initial models sometime in probably 2017. And then, in the interim period, what had happened was there was a lot of collaboration with many other producers across the country, but probably the most important one was work with the Federal Highways Association. There was a grant provided by the Federal Highways Association to UCLA. And the guys really accessed a lot of data from them directly as well. So it's been an ongoing progression. And I'd say the vast majority of data that we got access to was from a group of commercial producers right across the country that we started doing pilots with in 2021. And really the data set size grew exponentially at that point. So we had some initial work done on models and could start generating some outputs, and we were really good at prediction. But I'd say the kind of real acceleration has happened in the last 2.5, 3 years, and in particular in the last 24 months, where we've actually been able to pivot and move totally away from just prediction of existing mixes and really have truly generative artificial intelligence now that can tell a producer, look, based on what you have in your operation, these are the different combinations of materials I'd recommend to give you a certain output, and those outputs will still meet the required engineering requirements of that product.
I want to talk more about the continuing evolution of the back end of this, but let's first turn to the question of what it's like to use this. So, walk us through the Copilot experience. Is it something that the project manager uses to plan the concrete mix, or is it something that the workforce actually just uses in the field? And if so, do they need to be trained, or is it providing very simple guidance they just follow?
Yeah, look, the experience has really been designed around the user, and just contextually, the real, the folks that use the software are actually concrete producers. So if you look at kind of the construction cycle and you think of the developer, the owner right at the top, and they'll have an owner's rep, an architect, whoever, structural engineer, then you'll have the general contractor come in. They'll then have a concrete sub, and that sub may have another sub that does the placing. Ultimately, somewhere in that area, this is the group that really needs to get together with the general contractor at a bid submission stage to figure out what product they're going to be using. And ultimately, that group purchase from a ready-mix concrete provider. In the US, there's around 6,000 operations, and those 6,000 operations between them generate 415, 420 million cubic yards a year. Just context again, concrete is the second most consumed product on the planet after water, and there's probably 10 billion plus tons a year that are generated globally. In the US, that 420 million yards that I referenced earlier is the equivalent to building a Hoover Dam every 3.5 or 3.75 days. So the volume of this product that is generated is absolutely massive.
It is extraordinary how much concrete we use. Now, what are the benefits to the construction company using the system? Does it lower their costs? And if so, how long does it take to earn back the investment in the Concrete.ai platform once they've adopted it?
Yeah, so again, just referencing, it's not really the construction company directly that is looking at benefit. Ultimately, the opportunity we see them realizing is potentially the lowest embodied carbon product, if that's specifically what they're looking for. But it's really the ready-mix producer that is the one that is responsible for the design. So we're not really thinking about the production of concrete. We're thinking about the cake recipe that is required to meet the engineering requirements of that concrete element. So again, like I mentioned, 6,000 concrete plants in the US. A typical plant doing around 60,000 cubic yards a year is probably going to have somewhere between 300 and 1,200 unique mixed formulations within that plant environment. And those formulations ultimately give you a concrete product that meets a specified application requirement. So again, thinking of this, if I'm doing a commercial high-rise building, and I've got 20 different types of concrete applications, from a driveway, a pavement, the stairs, the column, a beam, suspended slab, all those kind of things. Every formulation is unique in that it is a different recipe based on the engineering requirements of that specific application. So, for example, a column typically would have a higher ratio of cement to the other products because you're looking to achieve a higher early strength. You probably would add a different type of chemical admixture to that as well to accelerate. And those kind of elements actually make that product slightly more expensive on a unit basis. And important to remember, concrete is sold volumetrically. So in other words, you're selling it into a form or a shape. You're not selling it by mass. And that's a really important thing to be aware of, because this ultimately allows for very, very high volume production. If you're producing more than 1 million cubic yards of a product in a day nationally, you've really got to be able to do high level production and at really at massive scale. And that's the reality. It's just so much easier to produce something volumetrically and provide it into a form that someone on the construction side is looking for.
However, at the end of the day, it is ultimately the project owner, whether it's the architect making the initial decisions about the cost of the project and so forth, that determine whether or not somebody's going to want a low carbon concrete.
For sure.
What is are you seeing real interest in that and growing uptake of low carbon concrete within the construction industry?
No, absolutely. And it's really interesting because you're 100% right. At the end of the day, it's our customer's customer that is the one that needs to be making the demand. In fact, our very first client is a company that builds data centers. And their mission is totally about lowest embodied carbon concrete.
Right.
And so what they actually ended up doing, they weren't self-performing, so they didn't actually have their own equipment on a construction site that they would then bring the raw materials to and mix. They would go to a producer and get that producer to provide them the lowest embodied carbon product for whatever application they were looking for within the data center. So they actually introduced us really early on in a project in Dallas, subsequently in Phoenix and in Washington, D.C., to producers, and then have been using our technology to validate that this is actually truly the lowest embodied carbon concrete. And in so doing, they've been able to save themselves typically in the order of around 20%. The reality was that anticipated that they were already using the lowest possible embodied carbon concrete, but we've been fortunate enough to come on board early on in the specification process and allow them to really reduce that number by an additional 20%.
So what is the business model for your relationship with the concrete producer? Is it a subscription?
Yeah.
How's it work?
Yeah, absolutely. So great question. We're a 100% B2B SaaS company. The way we operate is that we are firmly involved in utilizing only the producer's data, applying that data to our models, and for that reason, we're a straight subscription company. What we look to do ultimately is have a connection directly into an existing software system, which is normally a quality control system. And that is how we can extract underlying data, not only as it relates to the raw materials and their physical and chemical properties, but we are also then able to extract data as it relates to past performance of mix designs. And that really is what we then use to populate our models. We obviously have a pretty stringent filtering process to try and eliminate outliers. But then that becomes that kind of generic model gets developed specifically for the client. Very clearly, everything has to be firewalled. A client's data is their oil, right? So we've got to keep that as locked down as possible. But yeah, then we are able to really very quickly integrate, make that experience as seamless as possible. In many cases, we actually have an API built with the software providers, so kind of the transfer of data is very simple. But in cases where software providers don't want to do that for us, we would typically go to a system like a business warehouse, whether it be an SAP BW or a Domo or something like that, and actually able to go extract the raw data from there, populate our models with that, and then extract it and give the new formulations to typically the quality control person who would then enter it into the system again.
It's really interesting that you're already thinking about walling off the customer's data, because I don't think a lot of folks recognize how large language models are sucking up proprietary information and sharing it without that attribution. Where's the Concrete AI technology being used today?
So currently we deployed with 2 producers across the US. We're at about 20 operations right now. So the first commercial operations started going out in July of last year, the first commercial mixes, and so we've been extending our reach, so to speak, with our first client's a producer up in the Chicagoland area called Prairie Materials. Prairie is a subsidiary of a Brazilian conglomerate called Votorantim. And so this is a vertically integrated company. One of their arms within the organization is a cement and concrete organization, so vertically integrated both with cement and aggregate. And then a client we recently took on board, very fortunate to have them as a company called Titan Materials out of Greece, working with them on their East Coast in Virginia currently, and super exciting about where that relationship is going. I think, from our perspective, one of the challenges has always been deployment and the speed of deployment. And
All right.
building the connections into the data, but then also being able to get people's hands on the software, because I think the software really is intuitive enough for people at the design level to say, oh, yeah, I can figure out what iterations I need to go through and add different design constraints and get a mix out really quickly. I mean, from what we've been able to measure, it's typically a reduction of about 30 to 40% from a design process perspective. So we've literally gone from a 6-month integration because we had to do a whole lot of development on the API front, but we've literally got the deployment down to 5 weeks at an operational level right now, where people can actually start doing the design, getting these things into production, and going through the validation process. So the idea is really to get that down to probably a week or so with new data where we have an API built. It definitely takes a lot longer where we have to integrate into or get data dumps from a BW type system.
It's a really interesting story, Alex. I need to take a quick commercial break. We're going to be back in just a moment.
Great.
Now let's return to the conversation with Alex Hall. He's CEO of Concrete.ai. It's a lower carbon concrete mixing technology that uses artificial intelligence to control the mixing process. Alex, we've touched on the environmental benefits so far, and you've lowered the embodied carbon footprint of concrete on average about 30%. But is that just the first step? How much further do you think we can go?
It's a great question. I think you had a guest in your show recently, Grant Kreischer. One of the things that Grant does, I think, is really incredible, is looking for these cement alternatives. And in particular, their focus is around fly ash. I think we're still finding out the answer to that question. And I'm super excited because beyond products that Grant's bringing on, what we're starting to see is the deployment of at scale some really interesting technology. So recent announcements from companies like Sublime Systems up in Massachusetts, Forterra here on the West Coast. And these are really cement replacements. Super exciting to see where that goes to. Like I mentioned, we have a sister company that won the X Prize called Carbon Built. And we're also really looking forward to seeing how we can use our technology in the future from a deployment perspective with them to actually look at not just reducing the embodied carbon within concrete, but actually seeing how we could use a concrete type product. Probably it's going to be a precast versus a ready mixed product initially, but seeing how we can use our technology to actually increase the amount of CO2 that's being sequestered from the atmosphere. So yeah, super exciting, but maybe just something before I move on, just something to bear in mind. And it really is all a question of scale. Okay.
Right.
Globally, we produce somewhere in the order of 3.5 to 4 billion tons of cement. And contextually, cement is the component within concrete that, from an environmental and specifically carbon perspective, is the most detrimental.
Right.
I'm not vilifying cement. Don't get me wrong. I mean, I have a lot of arguments with many people about the benefits of concrete and what it's done. And frankly, I challenge anyone, and bring penicillin, you can bring whatever. But between concrete and cement specifically, and concrete, there's probably not a product that's done more for human lifespan than concrete on the planet. I mean, if you think about what the Romans were doing from a water transportation perspective, the opportunity we have from infrastructure, none of these things would be possible, and certainly not the growth that we've seen in the last 200 years without concrete or cement. That's just the reality. And an important thing to be aware of is that, I think, you've seen a lot of the studies that have been cited. We're probably going to have double the amount of buildings on this planet by 2050 than we do now. And that's a direct function, not only of population growth. We all know that's sort of tapering to some extent. But what you're actually seeing is that as people in countries become more developed and think about the global south with a massive population there that is definitely getting economically stronger, one of the realities is the energy consumption goes up, but the other reality is the amount of product that they consume in the form of concrete will go up as not only infrastructure gets better, but access to housing gets better and distribution networks get better.
China, over the past 30 years, case in point, they're building roughly a city every week.
Right. And so I think, for as important as the climate conversation is, and it is a critical one, I think we can all agree on that. You can't deny people the opportunity to advance. And this is something we've got to be faced with. So it's really incumbent on us to develop technologies in places like the US that are going to be easily scalable and deployable in other parts of the world. And really, that's a big part of our ambition. All things being equal, the deployment of a technology like ours to all the ready-mix plants across the globe would see a reduction, conservatively, of about 500 million tons of CO2 a year, just in being able to deploy this kind of technology across the planet.
And of course, with AI, you can deploy this in native languages all over the planet too.
Yeah, I mean, and frankly, the challenge of having developed this in the US was that the first thing we needed to do was convert it from our units into metric units.
Yeah,
that was the challenge. But yeah, one of the deployments we're looking at Canada, that was something I was really happy about, because that's one of the first opportunities we got to go and use the metric system and use the metric version now, and looking forward to seeing that go out in the next quarter.
We are quite contrary in terms of our use of measurements here, aren't we? So the other thing is, as I listen to what you're saying, you're a SaaS company now, subscription service, but could you begin to blend in not just recommendations about new materials, but partnerships to deliver those materials to your customers?
Yeah, absolutely. This is something we're looking at right now. One of the important things, and I think that this is not just true for the concrete industry, which tends to be historically conservative. And I mean small c conservative, because you can't afford a failure with concrete. It literally is a foundational component of a structure. And if you have an issue, it not only is it potentially going to mess the building cycle up, but it can kill people if it goes wrong. That's a reality. You have a concrete failure on a structure, people may die, and that's just not acceptable. So the reality of this is that we actually need to be mindful of these new products that are coming on board. But as mentioned earlier, provided we have enough data, we're actually able to simulate the performance of these products in replacement of other products within their customer's inventory. I think importantly, we want to be supplier agnostic. We want to follow the data, and we want to apply the data appropriately in the models to show people what the genuine benefit can be. But we're absolutely excited about some of the new stuff that's coming on board. And it's not just cement replacements, for example. I mean, we're working with some of the leading admixture companies in the world, and admixtures they're a tiny fraction of the volume or mass of cement. I mean, typically way less than 0.5%. But the impact these different chemicals can have is absolutely incredible in terms of the physical and workability properties, as well as the strength development properties of concrete.
Does that also suggest that you could replace other architectural components, steel, rebar, things like that, or plastics that are being used with forms of concrete?
I think ultimately yes, but I think for me the longer term, the 20-30-year vision probably is finding a way to deploy 3D printing at scale, because ultimately that exact thinking, so replacement of rebar, right? Imagine having a 3D printed beam, and using the right formulations, you could actually print the tensile members into the bottom of a beam, and then have a totally different formulation at the top of the beam, where you're not worried about the tension, you're more worried about compression. And so you could literally 3D print a formulation into a beam. I think the other thing that's pretty exciting for me around the 3D printing opportunity, and again, something we're happy to integrate with, is that typically because you sell concrete by volume, the shapes that we tend to pour the concrete into are not super complex. And what does that mean? Well, it means that a building is typically mass inefficient, and that there's 40% of the concrete that you don't need. Think of a column, for example, right? Column is typically, if it's a square column, you probably don't need all the concrete in that from a engineering perspective. You're looking at something more like an hourglass shape in terms of taking up all the loading. And
Sure.
so, that's a really interesting prospect we see going into the future. But again, one of the challenges is deployment at scale. And this is, again, one of the major issues we have with the cement substitution, because like I mentioned, it takes 10 to 15 years to get permitting and planning done for a cement operation. You build the operation on a reserve that's typically, anywhere up to, and most times exceeding, 100 million tons of raw material. You're building these things for at least 20, or 20 is ridiculous. It's probably at least 50 years reality from a production lifespan perspective. So in order to get these other substitute products in, these deposits have to be found. This process has to be gone through, and then, getting it done at scale is really going to be a challenge. So we kind of stuck with cement for a while. And I say that in the nicest possible way. I really believe in the benefits the product has brought to humanity. But we need to find technologies like ours that are deployable today that can have immediate impact. And the reality is, let's do as little harm as possible up front, and over time extend the validity of our type of technology in terms of being able to deploy it, where we can actually start finding ways to use it to see not just CO2 reduction, but ultimately CO2 consumption.
Implicit in what you just said is the idea that the design of buildings themselves will change. Just as we look back 100 years and go, look at those quaint buildings made of wood and rock, we're going to have a different generation of building over the course of the next 20 to 30 years. But in terms of what you just talked about, is the biggest challenge in terms of implementation getting on-site 3D concrete printing technology into use, or is it simply a matter of getting enough supply, and then the construction industry will solve the problem regardless of how they do it? Print offsite and move it on, or print on-site?
I mean, I don't think it's an issue, a capital issue. I think there's a lot of capital for crazy ideas out there, and I mean,
yes, you can just
even in this environment where you have a legitimate business, it's harder to get money for a legitimate business from venture than it is if you've got like a moonshot. The interesting thing for me, though, is I think construction as a whole is pretty conservative. From a technology adoption perspective, there's absolutely companies out there that are leading the race in terms of trying to be more inventive and finding better ways to do it. And we see all the digital twins and modeling programs that are out there to try and figure out how to do things as quickly as possible. But really, there's if you think about it, there really hasn't been a massive step change since the introduction of tower cranes and those kind of vertical lifts that have made construction that much quicker, and that's probably going on 100 years. Yeah. I think the challenge you have is that there's many different types of construction, many different types of owners. If you're a commercial developer, typically wants to get that structure up as soon as possible and start generating income off it, right? So what's the incentive there? Well, the deployment of a thing like 3D technology right now, you could do it, but you really struggle to do it at scale. One of the best examples to have a look at is have a look at the precast members that are needed for major civil infrastructure, and have a look at the size of those operations. To physically locate that on a small footprint in like a Manhattan or something like that is impossible. You just physically wouldn't be able to do that and use those elements on the building. You have to transport that stuff there. So I think we're still learning. We're still going to have to figure this out. Probably what you're going to see is an element of modular construction for civil engineering applications that gets applied to 3D printing. But yeah, I mean, I certainly don't have the answer. I kind of have a feeling and a excitement for where it's going to go to. I'm just really not sure that the ability to do that at scale, if it's not for, say, a large civil engineering project, a massive bridge or something, or a new dam, I don't think that opportunity is really here yet. But I'm really hoping someone proves me wrong.
Well, it'll be interesting to see how it turns out. Alex, this has been a fascinating conversation. How can folks learn more about Concrete.ai and follow your work?
Well, absolutely. We try and keep our webpage as up to date as possible. It's www.concrete.ai. Pretty simple. Yeah, if you go there, you'll find a lot of information about what we're doing. You'll start seeing some interesting things about existing projects that we're doing with clients. Some really impressive structures that are going up with our product. And then, the other thing, Mitch, just to throw this in there, but one thing that's really important for us is a focus on transparency. I think, it doesn't really matter how we got you, but there's already this impression in particular within the construction industry, I'd say, that there's this kind of greenwashing component. And
yeah.
The one thing we're absolutely dedicated to is this transparency as it relates to our product, and so specifically with reference to embodied carbon, we're working really hard to have additional bolt-on module that's going to be a part of the software that we're looking to deploy sometime in the second quarter that will actually give a lot more insight and third-party validation to the amount of CO2 associated with a specific concrete product that comes from one of our suppliers. So watch the space. I think it's going to be pretty interesting, and it's something that people really need to be aware of, that if you're going to improve something, you've got to measure it. And we have methods for measuring embodied carbon in products, and we're looking forward to deploying that really soon.
I think that's an important catalyst for adoption, and it'll be fascinating to see what comes of that. Alex, thanks so much for your time today.
Thank you, Mitch.
That was my conversation with Alex Hall, CEO of Concrete.ai, which distributes an AI-based concrete mixing system that optimizes the resulting material's performance and carbon footprint. You can learn more about the company and its relationship with UCLA, where there's a lot of materials innovation going on, at Concrete.ai. That's Concrete.ai. Check it out. There's an immense amount of progress on decarbonizing the built environment, but these stories are often complex and very esoteric. It's not easy to understand the innovations, and there's a widespread skepticism among the public about many green claims, justifiably so because of how much greenwashing is going on. Yet we also need to look up from the news about bad actors at the potential for real progress. As Alex explained, there are 6,000 concrete production sites in the United States, and Concrete.ai is working with just a few dozen today. It's very early days in a transition that could take a decade or more to really bear fruit. Now, there are a few clear benefits for new construction projects that use lower carbon cement and concrete, including a growing number of legitimate carbon credits that can significantly offset building costs while generating favorable ESG outcomes that can be shared with the public and investors. One big gap is the availability of third-party validation of these projects so that builders or homeowners thinking about pouring a new patio can decide to pay a bit more today for low-carbon concrete with confidence. And if we do so, then in the long run, the cost of low-carbon concrete will fall to and below that of traditional concrete, which is a source of about 6% of the emissions globally each year. It's an economic story, a story we're going to continue to follow on the show. Hey, I hope you'll take a moment to share this podcast or any of the more than 450 interviews we've produced on sustainability in your ear. Writing a review on your favorite podcast platform will help your neighbors find us. Folks, you're the amplifiers that can spread more ideas so we create less waste. Please tell your friends, your family, your coworkers. They can find us on Apple Podcasts, Spotify, iHeartRadio, Audible, or their favorite source of podcast goodness. Thanks for your support. I'm Mitch Ratcliffe. This is Sustainability in Your Ear, and we will be back with another innovator interview soon. In the meantime, folks, take care of yourself, take care of one another, and let's all take care of this beautiful planet of ours. Have a green day.